So here we're going to continue on the Unit 1, Lesson 1, Atomic Structure. We start last time on the problems that Bohr's model is put in. We said that Bohr's model improves the Rutherford model by saying, yeah, effectively, the atom has some roads for the electrons that we call orbits. But we said that there are two problems. The first problem, it is the jumps, how the jumps are done. The second problem, it doesn't explain the other atoms. So now we're going to go to big tree, quantum mechanical model of atom. Quantum mechanical model of the atom. So roughly what this model is saying, we're going to learn it if you do physics. It is saying there is a problem with how we're going to find the electron. Before we were following the electron. We said it is on the orbit. We're modeled with the Bohr, and it is orbiting, and when he will jump, he will go. So this model here, if we say that electron has a trajectory, has a way from jumping from one level to another level, we're not going to solve the first problem because it must be a continuous. So what physicists said? The physicists said, yes, the electron will make the jumps, but not continuously, not little by little. He will do them by once. He will jump or not. How in earth will happen this one? Yeah, we're not going to explain how, because electrons are waves also. That's what we call wave. Electrons are particles or waves. Electrons are also waves. So we're not going to go through this subject. But for now, we're going to say that the electrons can jump by make a mutation, and suddenly they are waves. They go through the wall, for example, and then they jump. So here, first, we can't know the trajectory of the electron. This is the quantum mechanics. We can't know the trajectory of the electron. They say this is impossible to know it. It is physics. It is impossible. There is no way. It is not that because we don't have instruments or we don't have, no. Physically, you can't. Yeah, it is impossible. And what we said, instead of focusing on the trajectory of the electron, we are going to focus on what we call the state of the electron. So the electron has the state. The electron has a state. What we will find in this state? In this state, there is the energy of the electron. If I want to know the state of the electron, for example, its energy is important. There is also a parameter called a spin of the electron. Okay, a spin, but because the electron, if you see it as a small sphere, it is spinning on itself. That's what we call spin, and it can spin on the right or on the left. That's what it has, two values of the spin. So the electron has a state. It has energy. It has a spin. Does it have a trajectory? No, that doesn't have any trajectory. Does it have a position? Maybe it has a position, but what is the position? We don't know. So the electrons has state, energy, and spin. Spin, as I said, and energy, it is the energy. Now, the physicist said we can't know the trajectory of the electron. The trajectory, it is the orbits. Donc, trajectory means orbit. The orbit of the electron, we can't know it. It doesn't have any orbit. So the physicist said I'm going to give you an example. Say we are looking for a fugitive, a criminal. He escaped. We don't know where he is. We can't follow him, so we don't know his trajectory, where he is heading. We don't know. We lost all the trace of him. What the police do? Generally, what they do, they say, we can't follow him. We don't know where he is. What we are going to do, we are going to follow where he can be. Where the places where he will be. That we call orbitals. Orbitals, it is places where the electron can be with 95% of with the probability of 95%, with a probability of 95%. This is what the police, for example, will do to catch the fugitive. They say, we don't know where he is. We're going to make some surveillance on his home, friends, for example, his work, the places where he likes to go. These ones we call them orbitals. If we can follow the fugitive, it will be orbit or the trajectory. But here we don't know. We don't know. So the physicist said we don't know the orbit of the electrons, and we can't know it. We can't. It is impossible to know it. Physically, it is impossible. But we can know the orbitals, the places where the electron can be. So orbitals where the electron can be. Orbitals where it is a space where the electron is likely to be. Space where the electron is likely to be. So this is quantum mechanics. And they said what Bohr said, it is true. Now, instead of jumping from an orbit to the orbit, they said jumping from state to the state. If the electron changes state, it will, by changing state, by changing its energy, because you can't change state without changing energy, change state by changing its energy, gaining by changing its energy, by changing its energy, it will absorb or emit a photon as stated by Bohr. So what will be the energy of the photon? The difference between the two states. So this is what quantum mechanics, what is the model, and now it is the model that it is working with. It is the correct model now. There is lots of experiments and there is no problem with it. The only problem it is for our conception. We say how the electron hasn't a trajectory. If he's moving from one place to another place, he followed some path. But this is what physics says. It says no, it doesn't follow any path. That's it. And now how the atom is represented. Now the atom, it is not represented as a nucleus and circles surrounding or ellipses surrounding. It is represented like what you see here. You see here the points. Here where they are more dark, it means the probability for the electron to be is huge. Here. Far from the nucleus, the probability to find the electron is slow or it is low. Like, for example, the fugitive. I'm going to return to the example of the fugitive. If the fugitive has no money, no car, So maybe we will catch him. He's still in the city. We say, ah, he's no money. He has no money. He has no car. Close the city. We're going to find it. That's what this means. For example, if the electron has not doesn't have enough energy, he will be close to the nucleus. So the chances to find him, it is here. Now, if the fugitive has more money and a car, fugitive has more money and maybe has a car. Maybe he changed already city. So we're going to close the province. We're going to find it. Province. If he has more money and more energy, maybe he fled the country. Okay, so he is in the country, etc. You understand. But for a fugitive to has a lot of money, it is unlikely. That's why, for example, if we go farther from the nucleus, we're going to find the chances to find the electron are the probabilities or the chances are very, very slim. But it does exist. So now what the atom that we represent the atom with the nucleus, and we put a circle, and here it is the chances to find the electron with 95%. Outside, it is the chances that electron it is with 5%. The electron can be 5% outside, but it means electron maybe it is on the sun or on the moon or outside. For example, the electron on my disk, one of the electrons of my disk, maybe now it is on the sun and it will return, will be replaced by another one. I don't know, but that's what means 5%. And we represent now the atom with this one here, opaque, and we see this is the atom. There is no circulars, there is no orbits, nothing, because we don't know where the electron is. So what we define, it's only orbits. So the orbits, the shape of the orbits, the shape of the orbits. What will be the orbits? Like, for example, the fugitive are after him. We say, well, can he hide in his home? How his home looks like? Is it a huge home? Small? What is it? He can hide where? Okay, and park. What is the form of this park? This is what the form of the orbits, where the electron can be, what are the orbits. And we have orbits, we have many orbits. The first orbit we call it S, the second we call it P, then D, then F. Roughly, S, you have small energy. If you are in the orbit S, what does it mean? It is you have low energy. I'm going to put it here. Low energy. High energy. What does it mean? S, it is close to the nucleus. P, little bit higher. D, little bit higher. F, more higher. This is S, P, D, F. And mathematically, how they look? They look like this one. The S orbital is circular. It is sphere. This is the S orbital. Sphere. P orbital. We have the P orbitals. They have the shape. We have each axis. We have two lobes here. Px orbital, Py, Pz. But if you want them all together, because this is the nature, they are all together. They looks like that. So the electron, it is like that. Like it's home. You can look at it. It's home. If he has more energy, it's home. It is like more energy, more money. Maybe he has something like that. Small energy. It is like that. So this is for the orbitals, S, P, D, and F. Now, how many electrons in one orbital? Okay, number of electrons for each orbital. Going to speak with this one here. Okay, so we have orbitals or suborbitals. I'm going to do here, yeah, orbitals, orbital, and suborbitals. You can look at orbitals like home and suborbitals like rooms, for example. So I'm going to make here a table, orbitals, suborbital. How many electrons we can put? So orbitals, this ones are suborbitals, but we call them orbitals. Maximum electrons, number of electrons, the maximum number of electrons, like rooms. Each room can take 2 electrons. Number of electrons, maximum number of electrons, max number of electrons. So orbital S, how many suborbitals? Only one. It is a home, it is a small home, it has only one room. You can write it house, rooms. And here number of person can be number of persons. Per room, it can be only 2. Maximum that can I have here 2. Why? Because I have one room, so I can't have more than 2. In orbital P, because it has more energy, it has more money, so it has 3 rooms. Each room can take 2, so it has 6 electrons that can be here. D, it has 5 rooms. It can hold 10 person or 10 electrons. F, it has 7 rooms and it has 14 electrons. You see here it is always by 2, 1, 3, 5, 7. If you have G here, it will be 9 and it will be 18 here. If we have H, it will be 11 and it will be 22, etc. You have always double this one here. So this is the orbitals, and each orbital, how many electrons it will hold. So if I go again to the orbitals here, for example, how many electrons I can put here? I can put 2. So in S, it has only 1 room. Here, how many rooms I have? I have 6, because this one has 2 rooms, 2 rooms, 2 rooms, because I have 3 houses. I have 3 rooms. This is room, 3 rooms. X, Y, and Z, and they can put an electron here, electron here, electron here, electron here, electron here, electron here. That's why it is 6. If I go to the D, etc., you understand the pattern, you understand what I mean. So I'm going to stop here, or there is other thing that I have to tell you. Okay, energy levels, we're going to do them on another video. Good, I'm going to stop here. Okay, bye.